Hello students, this is part 2 of a 2-part video series about the interim assessment number 2. We're doing a cumulative review of all of the topics that you'll see on that interim assessment. If you haven't already done so, take a look at the packet starting with question number 13. Try these questions out, pause the video, and then come back to see if you got them right. Alright, for question number 13, it asks which transformation would turn this new triangle, the image of this pre-image, ABC, into something that is not congruent. Remember that congruent means same measure and same size, and all three of these transformations are rigid motions. Rigid motions means the size do not change. However, a dilation, you should think of your pupil in dark and bright light. A dilation means the size does change, like it's going to get larger or smaller proportionally. So in all of the first three, reflections, rotations, and translations, these are rigid motions, which means the size don't change. But for answer number 4 rather, a dilation with a scale factor of 2 means that the shape is going to get twice as large. If it's got a scale factor of 2, that means it's getting bigger, which means it's not congruent, which means choice 4 is your answer. For question 14, after a composition of transformations, which is 2 or more transformations, usually on the geometry regions, a composition will mean only 2 transformations. These coordinates turn into these coordinates. You can see the 2 primes here. We call this A double prime, B double prime, and C double prime. That means that these have been transformed twice, not just once. So we're asked to figure out which composition of transformations was used. And we have this handy graph to help us. I can see that from A, B, C to A double prime, B double prime, and C double prime, the shape got smaller. The numbers also got smaller, right? 4, 2 became -2, -1. All of these sets of numbers became smaller. If the numbers get smaller, that means the dilation is of a fraction less than 1. Because if the numbers got bigger, that would mean I'm multiplying by a larger number. So I'm looking for a fraction less than 1 in my dilations. Choices 1 and 2 are out because this is a dilation of 2, which means it gets bigger. Dilation of 2, which means it gets bigger. 3 and 4 are the only ones with a dilation of a fraction less than 1, which is 1/2. Now I have to figure out which kind of rotation it was, either a rotation of 180 or a rotation of 90. You can see in the graph here that ABC went 2 different quadrants. It went to this quadrant here, and then this quadrant here. It traveled 2 different quadrants, which means it rotated not only 90 degrees. If it rotated 90 degrees, it would be down here. It would rotate 180 degrees, which means it comes here to this quadrant. 2 different quadrants means 2 different 90-degree rotation. That means it's 180 degrees of rotation. That's why I got choice number 3. For Unit 5, the congruent triangle proofs, these proofs were fairly straightforward. This proof had a segment addition postulate in it, which made it a little bit more difficult, but these are the kinds of proofs that you might see. Notice that both of these proofs use this parallel line idea, which means I'm going to be using one of the several different parallel line postulates. Some of those postulates include corresponding angles and alternate interior angles. You also need to know what alternate exterior angles are, consecutive interior angles and consecutive exterior angles. Those are things that you can look up in the other videos that I did for Unit 5. All right. I am not going to pause too long on this because you could obviously just pause the video to take a look at these. All right, moving on to the next page. On this next page, starting from question number 17, please pause the video, try these out, and then see if you got them right. It asks me for each pair of triangles to identify which postulates make the triangles congruent. These are the These are the 5 different postulates that you are required to know. This is side, side, side postulate, side, angle, 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 side, and this stands for hypotenuse leg. For question number 17, I can see that all 3 sides are known and all 3 sides are known, and we have matching pairs, right? CB matches up with DF, their corresponding sides. AB corresponds to EF, their corresponding sides, they match up. So that means I can use the SSS postulate pretty easily. I don't know anything about the angles, that's why I'm using side, side, side. For question number 18, it wasn't given to us, but I know that these 2 angles here are called vertical angles. They're across from each other, which means they are congruent to each other. They're formed by 2 intersecting sides, and they meet at this point, which is called the vertex. That's why they're called vertical angles, because they share a vertex. Trivia. Anyway, I know that this side partners up with this side partners up with this side, and these 2 angles partner up. That means I have a side, angle, side postulate. For question number 19, I'm given this angle, which looks like a right angle, but for God's sake, don't say that it's a right angle. It doesn't have one of those boxy sort of angle markers here, like it does in question number 20. It is not a right angle until it tells you it's a right angle. Just because it looks like a right angle, you can't say that it's a right angle. So hopefully I've ranted about that enough. Many students have gotten a question like this wrong because they assume, oh, this looks like a right angle, it's got to be a right angle. If it doesn't tell you it's a right angle, like here, it's not a right angle. Anyway, I know that this is a side, this is an angle, and this is a side, so side angle, side postulate. We call this angle in the middle an included angle. An included angle is between the two sides that are known. So included angles are between the two sides. If we knew this angle out here, this would not be an included angle because it's not between the two sides. For question number 20, I know it's hyp-leg or hypotenuse-leg postulate. There's a checklist of things that we need in order to use hyp-leg postulate. We need to have hypotenuse, which is the longest side of a right triangle. We need to have a leg, which is one of the shorter sides of the right triangle, and we need to know that it is a right triangle, so we need a right angle somewhere. This one wasn't marked, but we know that any side that is shared between two triangles is called the reflexive property. You want a real easy way to earn a point on a proof problem. Identify a side that is shared between the two shapes and call it reflexive property. That's usually worth a point. For question 21, MAD and MBC are congruent because of HL postulate. Again, I know that there's a right angle here, I know that there's a leg here, and I know there's a hypotenuse here. So that means this is hypotenuse leg. As a quick note, you can never, ever, ever say SSA or ASS postulate. That is not a thing. If you look back at the different postulates that we wrote up here, none of these say SSA and none of these say ASS. You can't use them. Quick mnemonic device is one of these is an inappropriate word to say out loud, so just don't say it. For question number 22, RTS is congruent to CBA because of AAS postulate. It's okay to use AAS postulate because it is literally written here. And I know that this is an angle, this is an angle, and this is a side that is not included. Notice that the S is not between the two A's. In this case, the side is not between the two angles. The side is called not included. It's not between the two angles. We're moving on to unit number 6. This is the last unit that we have to review in order for us to get a good grade on this interim assessment number 2. Which set can represent the lengths of the sides of a triangle? Well, I know that all of these lengths of sides of triangles represent possible triangles. I'm not going to try to draw these out using a ruler and try to figure it out. I'm going to use what's called the triangle inequality. The triangle inequality states that if I take the smallest side of a triangle and add it to the medium side of a triangle, that has to be greater than the largest side of a triangle. It should make sense to you, but I'll draw you a diagram to illustrate that. All right, you can see in these sets of triangles, the red side is always going to be the same length. The blue side is always going to be the same length, but as the angle here gets larger and larger and larger, that means that this green side is getting larger and larger and larger. The green side is getting bigger. The largest that this green side could possibly be is if these two lines were not in an angle, if they were in a straight line, which means that the green line would have to be exactly the same as these red plus blue. So if I added the red and the blue side, the small side and the medium side, that has to be greater than the larger side, because if it's equal to, that means that this line and this line are two straight lines. They don't form a triangle at all. So that means that these two sides, the smaller side and the medium side, have to be greater than the larger side. This is an illustration of the triangle inequality. Anyway, taking a look at these questions, or these answer choices, I should say, I take the small and the medium side, add them together. This is less than 10. Well, that's no good because it's supposed to be greater than. The smaller and the medium side are 2 and 4. That's 6. 6 is less than 7. Still no good. Supposed to be greater than. 11 and 11 is 22. That's less than 23. No good. Supposed to be greater than. And in this case, 7, 7, and 7. Well, I don't know which one is the small side and which one is the medium side, but turns out it really doesn't matter because there is no small, medium, and large side. They're all the same size. So that means 7 plus 7 is 14. 14 is bigger than 7. So this is our correct answer, 7, 7, and 7. You might also recognize that if you took these and put them into a triangle, that triangle would be an equilateral triangle. That's a triangle you've heard of before, so it's totally legal. Moving on to question number 24. This is the last page of the cumulative review. Please pause the video, try these out, and then see if you get them right. Here's another example of a triangle theorem that we went over in class. This is called the Triangle Inequality Theorem. it says that the longest side is across from the longest angle, or the largest angle. The middle side is across from the middle angle, and the small side is across from the small angle. So I'm looking at this triangle, which is given to me. Well, actually, it's not given to me, but remember, a scalene triangle ABC, I can just draw any triangle. So I drew any triangle, and I labeled it with the information they gave it to me, 45 and 55. And I also use the triangle angle sum, or the triangle sum theorem, to find that this angle is 80 degrees. So then it asks me the order of the sides in length, which means I'm going to look for the longest side, the medium side, and the small side using the different angle measurements. For example, in red here it says the longest side has to be across from the largest angle, which is 80 degrees. So the longest side has to be across the triangle, boom, BC. That's the longest side. Why did I cross off answer choice 1 and answer choice 3? Because it asks me to do it from longest to shortest, and I know that the longest side is going to be BC. That means it can't be AB, and it can't be AC. In blue, it says the smallest side is across from the smallest angle, which is 45 degrees. That's here. If I go across the triangle to the smallest side, boom. That means the small side has to be AC. Remember that I didn't draw this to scale. I just drew any old triangle, but I know that if this is the smallest angle, this must be the smallest side. So the smallest side is AC. That should be the last one on the list. The last one here on the list is AB. No good. The last one on the list here is AC. That's good. Just to verify, AB should be the middle side, the medium side, which means that AB should be across from the medium angle. This is the medium angle, 55, because it is between 45 and 80. Perfect. Moving on to question 25, we did questions like this in class together. We were asked to graph and label DEF. This is triangle DEF. And we're asked to find the midpoint of EF and DF. Those are G and H respectively. You remember the midpoint formula. Let me reintroduce it to you here. Remember, you do need to memorize this. So here's the midpoint formula. I found the midpoints G and H are 3, 0 and 2, -3 respectively. Here they are on the diagram. Incidentally, this line GH is a line that we talked about in class. It is specifically called the midsegment. And we're saying that GH is the midsegment of triangle DEF because it connects the midpoints of two sides of the triangle. This triangle could have 3 different midsegments. If I connected G to this midpoint over here, that would be a midsegment. If I connected H to this midsegment over here, it would be another midsegment. This is just one of the 3 possible midsegments of triangle DEF. So anyway, I found the midpoints and I found them here. Then I found the slopes. Why was I finding slopes? I have to prove that GH is parallel to DE, and I can prove that by identifying whether they have the same slope. It looks like here the slope formula gave us 3 for GH. It also gives us 3 for DE, which means these two slopes are the same. If they're the same slope, that means they're parallel. I can look at the diagram and say, well, they're basically parallel to each other. They're running alongside each other, but I need this mathematical proof so that I can prove it. All right, last but not least, in this problem, I'm looking for the distance formula because I need to prove that GH is equal to 1/2 of DE. I found GH first. I used the distance formula to find the square root of 10. I didn't simplify this because there is no perfect square that goes into or factors into 10, so I left it like this. For DE, however, I found the number to be the square root of 40, and I know that the square root of 40 has a perfect square inside of it. It has square root of 4 inside of it. So the square root of 40 is equal to the square root of 4 times the square root of 10. That means 2 radical 10 is DE. Well, it looks like GH is radical 10. DE is 2 times radical 10, which means DE is twice as big, or in other words, GH is half of DE. GH is half of DE. So I'm able to prove that just like that. Last question on the packet. In the diagram below, ABC has these vertices and is asking for the slope of the altitude. Well, an altitude is going to be perpendicular to the base of the triangle, and in this case, we need to find the base by what it gives us. It tells us I'm drawing the altitude from C to AB, so I'm going to draw the altitude here. So this right here is the altitude. Usually we use a dotted line to show the altitude, and I extended it through the base to show its slope. Anyway, that altitude is perpendicular to the base, which means this forms a right angle. And in order to make it a right angle, that means it has to have a negative reciprocal slope. So all I got to do is find the slope of AB, which is this line here. And I found that slope here, which is 7/1. And then find the negative reciprocal slope of that, which means take 7/1 and turn it into -1/7. There's our answer. All right, this video was designed to help with the cumulative review for the interim assessment number 2. Hopefully you got through this. And as always, good luck studying.